Welcome to the video tutorial for Unit 4, pages 11, 12, and 13 in the homework packet. So this is Day 5 homework. The first two pages, 11 and 12, are a summary of basically what we've been doing for the last week and a half in class. So it's mixed practice naming compounds. This is what your exam's going to look like all switched up. So there are representative metals here, which means they don't need Roman numerals. There are transition metals, which means they do. And then we also have polyatomics here. So we're going to need all kinds of stuff when we do this. The first thing it asks you to do is to circle all of the formulas that are binary ionic compounds. And they showed you an example. So binary, just like bicycle, means two or two wheels. So chromium and oxygen, there's only two capital letters, which means there's two elements and two wheels, right? Binary. So when there's parentheses like this, that means there's a polyatomic. That's called a ternary compound. Mercury and oxygen, those are only two elements. So that would be binary. That will be binary, this one's binary, this one's binary. Okay. When we get to here, titanium and cyanide, that's not binary, that's a ternary. But cadmium and chlorine and silver and chlorine and tin and chlorine and silver and chlorine again, interesting, it's on there twice apparently. And then cobalt and iodine. All of those would be considered binary. So go ahead and do the same thing down this column. Then we're going to come back and we're going to start naming. So anytime you see parentheses, it means that you're going to need your list of polyatomics right here. So I'm going to look up ammonium and go ahead and just write it. You copy this list exactly. AMMONIUM. And then for Cl, I'm going to change it to chloride. Okay. Binary ionic, when you end with an anion, that's just a nonmetal, we change it to ide. So let's skip down to some of these other ones. We're going to look at maybe these three, 16, 17, and 18 together. So Hg and O. There's no parentheses, which means no polyatomics, so I can leave that alone. Hg is mercury. And mercury is down here. Mercury is going to require a Roman numeral because it's a transition metal and it's not in our exception block. So I'm going to go ahead and write mercury. And then I'm going to leave a blank for my Roman numerals, mercury blank. And for O, oxygen, I'm going to change it to oxide. Remember, my binary ionic compounds are all going to end in ide, like these ones. So mercury blank, oxide. In order to find my charge of mercury, because this is going to be mercury charge in Roman numerals, I'm going to uncrisscross. And I don't have any subscripts down there. So that means there are invisible ones. I'm going to pull up a 1 here. I'm going to pull up a 1 there. It's always cation first, so positive, and anion second, negative. Now before I'm allowed to write down the charge for mercury, I need to double check the nonmetal's charge. So oxygen, according to this, makes a -1 charge. But according to our periodic table, it definitely doesn't. So on the periodic table, oxygen has 6 valence electrons. It wants to be like the noble gases. It wants to be like the nobility or the royalty. So in order to go from 6 to 8, it needs 2 more. So this would actually be a -2. So that means I have to double it. I had reduced this by cutting it in half, so now I need to double it. So -2, this one also gets doubled to +2. And I'm going to call it mercury 2 oxide. Coming down here for number 17, I've got zinc and sulfur. So I'm going to name the cation zinc. And then I have to check if it needs a Roman numeral. Zinc is a transition metal, but it's in my exception block. So zinc is one of the 2 elements in group 2b that always makes a +2 charge. Since it always makes the same charge, it does not get Roman numerals. I don't have to call it zinc 2. If it's zinc, I know it's 2. And then S for sulfur, I'm going to make it sulfide. If you said zinc 2 sulfide, you'd be wrong on the exam. So make sure if they're in this exception block, you're not giving it Roman numerals. Number 18, I'm going to name the cation, which in this case is titanium. And titanium is a transition metal, and it is not in the exception block, so it needs a Roman numeral. I'm just going to leave it as titanium blank for now. And then parentheses, that's showing me that I've got a polyatomic, so I'm going to come over here to my list and find Cn. Cn, just right there. So that's cyanide. I had a lot of students worried about the 2. The 2 is outside of the parentheses, so it means 2 cyanides. So I'm going to go ahead and just copy exactly. We don't change polyatomics. Cyanide. Okay, you're not allowed to change anything on this list. We just copy it exactly. So that'd be titanium and cyanide. Now, in order to find the charge that titanium's making, I'm going to reverse crisscross and pull my 2 up. There's nothing after titanium, which means it's an invisible 1, so I can pull that one up. There. And it's always cation first, anion second, so positive, negative. Now I need to check my anion, cyanide. According to my list, cyanide does make a negative 1, which means titanium is making a positive 2 this time. Titanium 2 cyanide. So really what this means is titanium is bonded on to 2 cyanides. Okay, that's why it's CN2 like that. Titanium 2 cyanide. Go ahead, work your way through these. I think hopefully by now you've got the hang of it. Let's go and flip over to page 12. Page 12, again, it's mixed practice, but now you're writing formulas, and they want you to circle all of the names below that are binary ionic compounds. Binary ionic compounds always end in "ide", but cyanide and hydroxide are exceptions. So cyanide and hydroxide are the only ones on this polyatomic list that also end in "ide". So that's how I'm going to check. Nitrite, that means it's a polyatomic, so it's not binary. Perchlorate is a polyatomic. Oxide, there's a binary. Cyanide, but that one's also a polyatomic. Remember, that one is a polyatomic, even though it ends in "ide". Hydroxide, that's a polyatomic, so be careful. Iodide, that one means it's binary. Oxide, that one's binary. Phosphate, ending in -ate like this, means it's a polyatomic. Nitride, ending in "ide", means it's binary. Carbide, that means it's binary. Dichromate, that's a polyatomic, so it's ternary, not binary. Sulfite is ternary. Selenide, alright, that one's binary. Sulfide is binary, and chloride is binary. Now it's going to be really important to know that, because anytime it ends in -ate or -ite, or if it's cyanide, hydroxide, you're going to have to copy from the common polyatomic ions. You're going to need this list for it. Mercury nitrite. First, there's 4 steps for writing formulas. Symbols, charge, crisscross, reduce, and erase. So the symbol for mercury is Hg. Symbol for nitrite, this is not nitrogen. Nitrogen, like this, would be nitride, I-D-E. This is nitrite, I-T-E. So this is nitrite right here. And remember, this is supposed to be a subscript 2 and a subscript 3. Your periodic table just had a little typo. So nitrite, I'm going to copy the symbol exactly, including parentheses. Parentheses NO2. Okay, so that's step 1, symbols. Step 2 is charges. This mercury is making a 2. It told me in the name. So positive 2. Nitrite makes a -1 according to my periodic table right here. Okay. So that's step 2. Step 3 is to crisscross. You cross around the parentheses. You're not allowed to go inside the parentheses. Okay. And then we reduce and erase. So for my students, I reminded you that ones are invisible. So it's going to be Hg, invisible 1, NO2, and there are 2 of them. Mercury nitrite, mercury 2 nitrite. Okay, continuing the Unit 4 video tutorial on pages 11 through 13. Let's work a couple more problems on page 12 here. So we just did mercury 2 nitrite. Let's look at beryllium carbide. This is a binary compound. Again, we still just write the symbols. Be for beryllium. Carbide means carbon, so it's just a C. It doesn't tell me the charge of the metal, which means I should be able to find it using the periodic table. Beryllium is in family 2, so it is going to make a positive 2 cation because it wants to lose 2 electrons. Carbon is in family 4A, or 14, and in order for this family to be like the noble gases, they need 4 more electrons. So to go from 4 to 8, I need to get 4 more. 4 more negatives makes it a -4. Now I'm going to crisscross 4, 2, and then we can reduce and erase. So remember, a 4 to 2 ratio like this, or a 4 halves, is the same as dividing that by 2. That's equal to 2 over 1. 4 halves is the same as 2. Okay. So I can reduce this down to 2 and 1, and 1s are invisible. So it's going to be beryllium 2 carbon invisible 1. Now the important thing to remember there is if you leave it as Be4C2, it would be wrong. You have to reduce if you're able to. Alright, let's pull one more. How about titanium 2 sulfide? Ooh, and you know what? That's a typo. It says S-I-F-E. Let's pretend like that says I-D-E. That's a typo. I hit the wrong letter there. Symbol for titanium is Ti. Sulfide is just sulfur. Remember, sulfate is this one down here. Sulfite is this one. But sulfide, I-D-E, is just sulfur. So that's step 1 symbol. Step 2 is charges. It's telling me right there that titanium is making a 2 charge. And since titanium is a metal, it's a plus 2 charge. Sulfur is in family 16, which means it has 6 valence electrons and it needs 2 more to get to 8. So it would want to get 2 more negatives, which would make it negative 2. So when we crisscross the 2 and the 2, we're going to switch those places down as subscripts. And since they're both the same, they cancel out. So it's TiS, titanium 2 sulfide. Alright, in class today, it's also attached to my website, but in class today, you got page 13 in the homework. Ding, ding, ding. You have to turn this one in as well. So this is what we did in notes today. It was molar mass. So the first thing you need to do is count the atoms. We did this one in class, so let's skip down to number 3. Okay. And we've got a little typo here, so I'm going to go ahead and correct this. So this one says moles of N and moles of H. That would definitely be moles of cobalt, CO, and moles of chlorine, Cl, because those are my 2 elements in cobalt chloride, cobalt 2 chloride. So, how many moles of cobalt do we have? That's the subscript. How many subscripts do we have? So it's an invisible 1 right there, which means I have 1 mole of subscript, 1 mole of cobalt, and I have a subscript of 2 for chlorine, so I have 2 moles of chlorine, which just means that every 1 cobalt is going to be bonded on to 2 chlorines, kind of like that. Okay, and it's an ionic bond, so it'll be a positive 2 is attracted to these negative 1s magnetically, electromagnetically. So it's a 1 to 2 ratio, 1 moles to 2 moles. And then I'm going to multiply each of those by the mass of a mole. And the molar mass is the same thing as the average atomic mass. So I'm going to find cobalt's on here, right there. Cobalt's average atomic mass is 58.933. So 58.933. And then for chlorine, it's over here, 35.453. Okay. So each mole, there's 1 mole, and it weighs this much, so 1 times this equals, that stays the same. That's the total mass of cobalt. Then 2 times, I have 2 moles of chlorine. Each mole weighs 45.453, so I'm going to turn this on. 45.453 times 2 moles, because I've got 2 of them, is 90.906. Now remember, you're not allowed to round on this at all. Okay. So my total mass of cobalt is this, my total mass of chlorine is this, so I need to add them together. So I'm going to go this answer plus 58.933. My total molar mass will be 149.839 grams per mole. There's my answer for cobalt chloride, cobalt 2 chloride. So let's come down here and try one of these. Number 7, calcium phosphide. You're going to have to write the formula for this one. So phosphide, calcium is Ca, phosphide is phosphorus because it ends in "ide." So there's the symbols, the charges. Calcium's here in family 2, so it makes a positive 2. Phosphorus is in family 15, so it needs 3 more electrons to make a negative 3. Crisscross, reduce and erase. The formula is Ca3P2. Alright, now we didn't give you the spot to show your work for these problems because you should know. So, I've got, for calcium, I've got 3 moles. Each mole has a mass of 40.078, right there, times 40.078. That's going to be my total mass of calcium. For phosphorus, I've got a subscript of 2, which means I have 2 moles of phosphorus in this compound. times each mole of phosphorus weighs this average atomic mass, 30.974. And that's going to be my answer for moles total mass of phosphorus in this compound. So let's go ahead and do that work now that we've got it shown. You have to show work for these problems for credit. 3 times 40.078 equals, my total mass of calcium is 120.234. Okay. And I'm going to go 2 moles of phosphorus times how much each one weighs, 0.974 equals 61.948. So all of the calcium in this compound weighs this much, all of the phosphorus weighs this much. We add those two answers together, so plus 120.234 equals my total molar mass of calcium phosphide, 182.182 grams per mole. Just like that. Okay. Well done, y'all.